Hi guys, and welcome back. We've been talking a lot about the structure of the atom and the atomic number, atomic mass of late, and we're now going to be talking about the varied types of atom, so to speak. So you can actually vary the particles within the atom. So we've already said the nucleus of the atom contains the proton and the neutron, and then you've got the outer shells, the outer orbitals that contain electrons. And in chemistry, you do get variations. Obviously, changing the proton obviously changes the element. So by going from hydrogen to helium, which you've already seen, you're changing the number of protons from one for hydrogen to two for helium. But we can also see changes in the number of neutrons. We'll get to the changes in electrons further into the video, which is what we're going to be discussing here. So whenever you have an atom, an element that's got a different number of neutrons in it, like we have carbon here, for example, we call that an isotope. So while it's the same element, it is still carbon. So we've got carbon 12, which has got 12 neutrons in the nucleus there. You can see six, but I presume you can see five there, but I think the number six is hiding behind those somewhere. So essentially, you've got equal numbers of protons and electrons there in that nucleus. So that is what we call carbon 12, and that's perfectly fine. The nucleus is quite stable there, and you see carbon 12 quite often in nature. In fact, carbon 12 is one of the more common of the elements, and it underpins organic chemistry, to be fair. So you've all heard of things like vinegar, alcohol, things like that. These things are made of carbon with a mixture of carbon 13 in there. I've just said the carbon 13, so we better take a look at that. So what happens then if you put another neutron into the nucleus of carbon? Well, what we end up with is it's still carbon because we have only changed the number of the neutrons. We have not changed the number of the protons. So by adding an extra neutron in, what we do is we change the isotope. So we have gone from what we call carbon 12 to carbon 13. So as you can see here, nothing has changed. We've still got the six electrons orbited around the outer nucleus. We've got the two shells, so the inner orbital and the outer orbital. I realise I've jumped on ahead a bit there. We are going to get to that, so just bear with me. But you can see here the mass number is now 13, and that tells us that we've now got, so we've got the atomic number of six. We have got six protons in here, and atomic mass of 13. So that tells us 13 from 6 leaves 7. So we've got 6 protons in there and 7 neutrons. And that is totally and utterly fine in nature. That just simply means that the carbon, you've got carbon 13 atoms out there mixed up with carbon 12. And the difference is they contain that one extra neutron. That chemistry matters in radioactive chemistry. Not something to discuss here, but it's down to as you add more and more into a nucleus, you then bring in questions the stability of that nucleus, and then that's when you start losing particles to get the stability, and that's when you get radioactive properties forming. But for your level, all you need to be aware of is what isotopes are. So once again, when you change the number of neutrons in the nucleus of an atom, you are changing not the element, you are changing the isotope. So the element remains the same. So you've got carbon 13 and carbon 12. These are both these are both the carbon, but the isotope has changed. So that's another thing you need to be aware of for your GCSE chemistry. And what I've done here, I'm not putting the negatives and the positives, but there's a color code here so you can see which is which. And up here you can see you've got the carbon symbol of C, and you've got the mass number at the top of 13 and the atomic number of 6. So moving forward, when I talk about elements, I'm going to try to keep to this format for you. And down here it tells you what's in there. So you've got the 6 electrons, 6 protons, and 7 neutrons. And up here, you've got the 6 electrons, 6 protons, and 6 neutrons. So by varying the number of neutrons in the nucleus, you are changing the isotope of the element, not the actual element itself. That's the key takeaway from this brief tutorial. When we next come back, we'll be talking about what happens if we alter the number of electrons in the atom. See you then.